All right, so we're going to go over the FRQ that I had you work on. So I've gone ahead and I've written down some of the initial things. So dy dx is equal to y squared times 2x plus 2. Let y equal f of x, and then also you've got your initial condition of f of 0 equals -1. So part A, they want you to find the limit as x approaches 0 of f of x plus 1 over sine of x. So if you plug a 0 in, f of 0, they told us was -1. Well, -1 plus 1 is equal to 0. If you plug a 0 into the denominator, sine of 0 is also equal to 0. So we get a 0 over a 0, which means that we can use L'Hopital's rule. L'Hopital's rule says that you are going to take the limit as x approaches 0 of the derivative of the top, which is f prime of x, over the derivative of the bottom, which is cosine x. Okay. Now, when you plug a 0 into the numerator, you want to find f prime of 0 over cosine of 0. Well, we know cosine of 0 is equal to 1, so we know the denominator is equal to 1. We need to find what f prime of 0 is. Well, f prime of 0 is just the derivative at x equals 0. Well, here, right here, is our derivative function. So f prime of 0 is going to equal y squared times 2x plus 2. So you know that x is equal to 0. Well, what's y? Well, think back, or look back at your initial condition. When x equals 0, y is equal to -1. So you have -1 squared times 2 times 0 plus 2. So that's positive 1 times that's a 0 plus 2 is a 2. So it's going to equal 2. So for part A, your limit is x approaches 0 equals 2. Now, I believe, I don't have the answer key right in front of me, but I do believe you got 2 points for this one. The first point was knowing to use L'Hopital's rule. So if you're showing that you're using L'Hopital's rule, you're getting a point. Then you got another point for doing the final answer. So that was 2 points altogether. L'Hopital's rule, and then the answer. All right, let's look at part B. Part B said, use Euler's method starting at x equals 0 with 2 steps of equal size to approximate 1/2. All right, well, the first thing I know I'm going to have to do is I'm going to have to make my chart. Now, if you're looking at the answer key as I'm making this chart, you notice that they didn't use a chart. They used some sort of a formula. Well, there are 2 ways of solving Euler's method. You've got the chart kind, and then you've got the formula. I figured you already had enough formulas to memorize, and I like the chart better. It flows better. It makes sense to me without having to just fill in values into a formula. Now, I believe Khan Academy does use the formula, so if you're interested in looking to see what the formula is or how to use it, you can log on to Khan Academy. Just ask for Euler's method or type in Euler's method, and it will lead you through. All right, so I have x equals 0. I need to get to x equals 1/2, and they want 2 equal steps. So half of a half is a fourth. So I'm going to go a fourth, and then I'll get to a half, and this right here will be my answer. So I went a fourth of the way. So that means my change of x is a fourth. Okay. Now, when x equals 0, y equals -1, so I go ahead and fill that in first. Now, my derivative is y squared times 2x plus 2. So I have to put all of this stuff in order to get dy dx. I'll go ahead and use my calculator for that. So I have y squared, which is -1 squared, times a 2 times 0 plus 2. Now we just did that. We knew it was going to be 2. So we've got our 2 right here. Okay. Now your change of y is 2 times 1/4, which is just going to be 1/2. So we end up with -1/2 plus a half, which is a -1/2. Okay. Now go to the next one. Now consequently, this was not a calculator problem on the AP exam. So you would have mathematically had to do it, but the math wasn't too hard right there. You'd already answered this one. You already knew the derivative was 2. So really, you're only plugging in one more thing. I'm just going to continue to use my calculator so we can kind of speed things up. So I got negative 1/2, which you could just do 0.5 squared times a 2 times a 1/4 plus a 2. And I end up with 0.625. Now, if I was doing this mathematically without a calculator, I would have gotten 5/8 as my answer right there. Okay? Then 5/8 times 1/4, I would have gotten 5/30/32. So negative 1/2 plus 5/32 gives me a negative 11/32, which is my final answer. So you're approximating, what was it, f of 1/2 was approximately negative 11/32. We do not know the function, so we don't know how close we are. I do believe this was also 2 points. I wonder if I can take a look at what it was on. So 1 point was for Euler's method, so just showing that you're using Euler's method. So whether you were going ahead and you were doing, if you were going ahead and doing the chart, or if you're doing the formula, as long as you're doing Euler's method, you get a point. So just to show competency in that, you get a point. Even if some of these numbers are wrong, some of these fractions are wrong, you get a point for showing that you know Euler's method. Then you get a point for your answer. So if you got your negative 11/32, you've got your answer. Let me see how they answered on theirs. Yep, negative 11/32 is what they said next. All right, so next, our last one, the differential part, part C. Part C says, find y equals f of x, the particular solution to the differential equation with initial condition of f of 0 equals negative 1. So we're solving our differential equation. Now, first thing I got to do is separate my variables. So I'm going to put my x over here. I'm going to divide by y squared. So dy divided by y squared equals 2x plus 2 dx. Now, I can't integrate this here, so when I integrate it, I'm going to want to pull it to the top. So I'm going to integrate y to the negative 2 dy, and I'm going to integrate 2x plus 2 dx. So this becomes y to the negative 1 over negative 1, and this becomes 2x squared over 2 plus 2x plus c. Don't forget that, plus c. All right, so I kind of need to clean this up a little bit. I'm probably going to bring it up here. So y to the negative 1 over negative 1 is negative 1 over y equals an x squared plus 2x plus c. Now remember, when you're solving differential equations, you always have to solve for y. So essentially what we're going to do is we're going to multiply both sides by y. And then you can see here, I got to divide by all that stuff. So negative 1 divided by the x squared plus 2x plus c is equal to the y. Ooh, I forgot to solve for my c. Let me go ahead and solve for my c over here, and then I'll plug it in for you because I forgot to do it before. So let's say we've got negative 1 over y. Now they told me y was equal to negative 1 and x was equal to 0. So I find out that 1 is equal to c. Okay, so I can come over here and I can just put a 1 in right here. I can put a 1 in right there. And I have my final answer. Okay? Now, taking a look at the answer key. The answer key, this is worth 5 points. You've got your first point for the separation of variables. So if you did the very first thing we did right here, where we went from this to this, you get a whole point. Now they want you to integrate. So if you integrate this side and you integrate this side, you get a point. Now, what if you just get half of one? I don't believe you get a half a point. I think you've got to do both derivatives or integrals correctly in order to get that point. constant of integration. It just means that you put in a plus c. You get a whole point for putting in the plus c. We're up to 3 points already. Uses the initial condition. We almost forgot that. Well, I almost forgot that. Make sure you plug in your initial condition. You get that c is equal to 1 and plug it in. Okay? Then you solve for y. So that last point is going ahead and multiplying both sides by y and dividing by your equation. Now you might notice that they then factored this down here in the bottom. You do not have to factor it. That was just an extra step that you do not have to have in order to get your 5 points. Now notice it says max of 2 out of 5 points if no constant of integration. So if you don't add this plus c, you're done at 2 points. So you do want to remember your plus c. Now also notice that it says 0 out of 5 points if you haven't separated the variables. So you have to separate the variables first. Not really sure how you do it otherwise, but do make sure that you separate those variables first before you then move on. All right, so that is the explanation for the AP problem.